All right, so I'm skipping to question number 7 because the other 4 questions are more or less the same. There's one more additional type, but it's not significantly harder compared to the rest. All right, so question number 7 is asking, how do we know how many scan lines, diagonal scan lines, are between 2 pixels? Okay, so that's including the lines that those pixels are located. All right, so this question is um, it's actually very easy to answer in a certain way. Okay, so you are allowed to apply G inversed twice. So once you perform G inversed, then you end up with the xy coordinate corresponding to in my case, this integer here and also this integer over here. So you can refer to the notes, the wn thing, and then just kind of use that to help figure out the xy coordinate. So you can figure out what is the xy for this one, and then you can figure out the xy for this one over here. Um, I'm not I'm not going to solve that. You guys have all seen how I did it with a spreadsheet, right? So you can probably use the same spreadsheet, on your side and do the same thing. So all I'm going to do is to say, let's say the inverse of 56,568 is x1, y1. Okay, so we'll say x1, y1 is the result of G inversed applied to 56568. Okay, there we go. And then we'll also make the assumption for the other one. So let's say x2, y2 is the result of G inversed applied to 122,494. Okay, so here's the thing. Okay, um, every for every diagonal line, when you add when you add the x and the y coordinate, they add up to the same value. Okay, so this means w1 equals to x1 plus y1 is the sequence number of the diagonal scan line that contains x1, y1, and likewise w2, which is the sum of x2 plus and y2, is the sequence number of the diagonal scan line that contains x2, y2. All right, so now that we have w1 and w2, we have to be inclusive. So we just have to count how many lines are including w1 and w2 and everything in between. So we can say now the number of scan lines all together. Oh, come on. I cannot type together. Is w2 minus w1 plus 1. You have to do the plus 1 because let's just say that w2 is right after w1, then you still have 2 lines. Okay, so that means you have to use a plus 1 to adjust for that. So there you go. We have question number 7 answered. Sort of, okay, because I did not actually solve for x1, y1 or x2, y2, but that's really just plugging in, as one of you suggested. So do we just kind of plug in the values and get the result? Well, when you know how to apply all of these reasoning, sure, I mean you can just kind of plug it in, figure out what is x1, y1, figure out what is x2, y2, just kind of look at the sum of x1, y1 and the sum of x2, y2, do the subtraction, and then do the plus 1, and that would be the number of lines in between. And this really has to do with how the G function itself is defined, how I do the kind of scanning. and it was actually mentioned in the module that this characteristic is particularly useful when I needed to derive the inverse function for g. So there you go. So I'm gonna stop this recording and send it online.